Yes students, now we are going to learn 6 ray diagrams for converging optical elements like concave mirror and for convex lens. For convex mirror and concave lens, diagrams are very easy, single ray diagram exists. So here we have to remember that both ray 1 and ray 2, 1 and 2 come from the head of the object. Both reflected ray 1 and ray 2, incident rays will correspond to object's head. Reflected rays correspond to object's image head, and this principal axis will take care of the tails of the object and image. Anyhow, we are taking point objects, but this is not a problem now. So let us take the first ray diagram. Read it. If object is at infinity, then image will be at focus and its characteristics are real, inverted and point size, which we call it as highly diminished. So this is coming from the head of the object from infinity, parallel like this. This is also incident ray number 2 coming parallel to the principal axis from infinity. First ray reflected, second ray reflected, both passed through a point. That point sized image we got it. So wherever incident rays meet, that is object. Wherever reflected rays meet, that is image. Similarly, this ray is coming from head of the object. This ray is coming from the head of the object from infinity. After refraction from the convex lens, they pass through a point. And these two rays are refracted rays. So these two are incident rays, these two are refracted rays. Meeting point is a point object. This is real object because you can keep a screen and capture this. Inverted and point size, highly diminished. Now quite opposite. Infinity object comes at focus. If I keep the object at focus, what happens? So this point is focus where I kept the object. So one ray comes like this, goes to the focus as per the rules of ray tracing. The other ray coming to the principal pole makes equal angles. This angle and this angle are equal. This is like a parallel railway track. These tracks will not meet. These rays, if you extend it backward or forward, they are not going to meet. Now read. If object is at focus, then image will be at infinity. So image is not formed. As rays do not meet, no image is formed. Hence we don't comment on the characteristic like real, virtual. That kind of words are not supposed to be used. Similarly, this is the convex lens and I keep the object at focus. One ray passes through focus. The other ray goes undeviated as per the rules of ray tracing. Now if you extend this ray, it's like railway parallel track. So this will not meet here if you extend it, or if you extend it backward also they don't meet. So same story. If an object is at focus, then image will be at infinity. As reflected rays do not meet or refracted rays do not meet, image is not formed. Hence no comment on characteristics. Object at infinity, image at focus. Object at focus, image at infinity. Object at infinity, image at focus. Object at focus, image at infinity. This is the two important ray diagrams. Now we are going for the next two. Let us see this. Third, the numbering is given, reasoning behind it I'll tell you later on. First, let us understand the basics. If object is at the center of curvature, so two incident rays come from the head of the object. One passes through focus which is parallel to principal axis. One makes equal angles such that these two reflected rays meet at a point, that is your image. Real, inverted and same size. Two incident rays from object, two refracted rays to form an image. Both are of same size. Read it. If object is at center of curvature, then its image will be at center of curvature. Center of curvature, center of curvature, center of curvature, center of curvature. Real, inverted and same size. Now comes the next two. If object is beyond the center of curvature, then image will be between center of curvature and focus. Real, inverted and diminished. Let us see this. This object, this is center of curvature, little beyond it we keep it. Two rays which are incident from head of the object. After reflection, two rays pass through head of the image. This image is inverted because left side is real, right side is virtual. It's a real image and it is inverted image. Real, inverted. Compared to this is small size, diminished image. Same thing. This object in case of convex lens. These are the two incident rays coming from head of the object. One after refraction passes through focus, one goes undeviated and they pass to the head of the image. So this image is formed between focus and center of curvature. This image is formed between focus and center of curvature. Read again. If object is beyond the center of curvature, this is center of curvature beyond, this is center of curvature beyond, then image will be between center of curvature and focus. This is in between these two. In between these two. Real, inverted, diminished. Now quite opposite to this. If I keep object between these two, what happens? So if object is between center of curvature and focus, if object is between center of curvature and focus, two rays, incident rays coming from the head of the object, one passes through focus, one goes undeviated. One passes through focus, other makes equal angles. So both of them is going to meet at some place, that is heads of the reflected rays meet at image. Heads of the refracted rays meet at the image. So two incident rays meeting point is head of the object. Two refracted rays meeting point is the head of the image. Tail is taken care by this principal axis. Now see, read it. If object is kept between center of curvature and focus, then image will be beyond the focus. Now you kept between center of curvature and focus, you got image beyond center of curvature. You kept between center of curvature and focus, you got image beyond center of curvature. Because it is right side for the lens it is real, left side for the mirror is real. So here is a real image, inverted image, compared to the object is big. So it is magnified image. Now comes the last one. If you keep this is the focus, this is the focus, less than the focus distance if you keep the object within the focus, then one ray passes through focus like this, other ray makes equal angles, and this extension gives you an image which is virtual, erect and magnified. Because for mirror left side is real, right side is virtual. Similarly for lens, this ray comes and passes through focus, the other ray goes undeviated. If you extend these two rays, they extend backward. Right side is real, left side is virtual for mirror lenses. So you'll get a same virtual, erect and magnified image. Read it. If object is within the focus between F and P, then image will be on the same side as that of object, virtual, erect and magnified in case of lens. But in case of mirror, it will be on the virtual side, other side. So now practice these ray diagrams from, we are given random order. You see here, after 1 we went to 5 feet, 5 to 3, 3 to 2, 2 to 4 and 6. Because I wanted to show you 2 and 4 are quite opposite. I wanted to show you that 1 and 5 are quite opposite. But actually you have to practice 1, 2, 3, 4, 5 order. That is, you have to come from infinity to beyond center of curvature. Then to, that means you have to start from infinity to center of beyond center of curvature, towards center of curvature, middle of the center of curvature and focus, then come to focus, then come to within the focus. In each case, how the difference image size is going on increasing, that you can understand it. This is all about ray diagrams.